suka kita buat bangunan, kita buat kenderaan. So dia akan ada potential benda tu digabungkan. Tapi in our course, we look at this separately. We treat every problem tu separately. Kita tak consider pun in our course the combination between the two different type of structures to beam, sebagai yang saya bagi tahu tadi, beam campur dengan trusses, beam campur dengan frame, tapi the concept dia sama je. For example, kita dah tengok bar problem semalam dan minggu sebelum ni kan. And then today we are going to look at the plane trusses. So kalau kita ada combinations of bar dengan plane trusses, so kita mula-mula kita treatkan dia mengikut equation mereka sendiri. Kalau kita ada combination of bar dengan plane trusses, part yang bar kita solve pakai bar equation. Part yang plane trusses kita solve pakai plane trusses punya equation. Nanti bila elemen K elemen yang bar, K elemen yang plane trusses tu, nanti kita akan assemblekan dia. Okay, kita perlu assemble untuk menjadikan dia sebagai satu structure yang the full structure yang kita nak solve kan. Okay, tapi itu just for your general understanding. Tapi kita tak go to that stage. Tapi saya rasa in the near future we will introduce that kind of a problem mungkin dalam final exam lah. Sekarang ni kita tak sampai ke situ lagi sebab I think that is very important. Bila kita solve part by part ni, kalau student yang kreatif dia dapat tangkap benda tu. Benda ni tak akan berlaku ni kalau plane trusses, the whole structures, kereta plane trusses je kan. Tapi mungkin we will introduce the combinations of different elements tu lah. Alright, tapi untuk this topic, let's we look at the plane trusses. Apa itu plane trusses? Dekat mana kita jumpa plane trusses? And then how we can use find the element in solving these plane trusses problems. So in term of the introductions, saya rasa tak nak sentuh banyak kat sini. Nanti you all boleh tengok dekat saya punya recorded lectures dalam YouTube. Tapi in general, plane trusses is a static structure. So dia adalah static structures. Okay, static structures consist of straight slender members. Slender ni maksudnya kurus lah. Okay, interconnect adjoint to form a triangular unit. So that's mean macam kita ada bar kan, kita ada bar, bar ni kurus. Bila dia kata slender tu dia ada certain L over D lah. Let's say diameter dia D, L dia length. So untuk slender members, biasanya L over D, dia punya value dia big value lah. L much more larger than D. And then dia cakap intersect at a joint. So biasanya at the end of this slender members ni kita treat dia sebagai joint lah. And then dia cakap to form a triangular unit. So kalau nak jadi triangular unit kena ada berapa? At least kena ada 3 kan. Okay, ada 3 slender members. Okay. So the joint here is the what we call it the connected joint that will connect the 3 slender members. So type of trusses ada pitch trusses dengan parallel cord. So nanti you all bacalah yang tu sikit je tu. And then this is an example of the pitch trusses. So kalau kita tengok dia ada elemen yang triangle tu. Kita ada this is meskipun dia nampak besar, dia still slender. D dia kecil, dia punya L dia lagi besar. And then So dia ada elemen yang berbentuk triangle. And then bridge. Kalau siapa duduk dekat area-area kampung tu, dekat bridge laluan kereta api biasanya bentuk macam gini kan. Okay, jambatan-jambatan kereta api yang lama-lama dulu biasanya dalam bentuk macam ini. So this is a type of pitch trusses as well. And it is very very strong. Kereta api yang berat tu pun dia boleh tahan. And then another type of trusses which is dekat sini dia panggil complex trusses because as you can see here, these small trusses, yang segitiga-segitiga kecil ni, dia dicombinkan menjadi satu macam slender members. Okay, jadi satu slender members yang besar. And then another yang dekat sini ni, to make another slender members lagi kan. And then dah ada dua big slender members. And then we have yang kecil-kecil lagi ni kat sini ni, okay, dia menjadi membentuk macam slender members yang lain. So dia interconnected at joint to make another big what we call it truss structures. And then ada lagi ni, yang ni macam beam ni, yang ni beam. So as you can see here, small trusses can make up a big trusses. So ini pun untuk jambatan ni. And then plane trusses is very famous in aerospace construction. And then there is another type of truss which is called viridial truss, also used for bridge, and also it has been reported was used for the constructions of the Twin Towers. All right, so as we can see here, a truss can be found almost anywhere. Bridge construction, aerospace, satellite construction, building construction, and maybe you can see for the roof construction as well. Yang ni saya tak tahu kenapa ada gambar dia kat sini, apa kepentingan dia pun saya tak tahu. Sebab slide ni pun dia jangan ambil daripada orang lain. Ini pun nak cerita pun banyak konspirasi. So kita tak boleh cerita itu. Alright. Now we comes to plane trusses. This is the strategy how we can solve plane trusses using finite elements. So it's mentioned here. Okay, saya baca dulu dan saya akan explain lah. A typical two-dimensional plane trusses is shown. So this is adalah typical plane trusses, macam jambatan tadi kan. It comprises of two force members. Dia ada two force members connected by frictionless joint. So this is the keyword yang kita kena ingat ni. Pada joint ni, dia macam rigid punya connection. So dia bukan frictionless joint. Maksudnya dia adalah frictionless joint. And all loads and reaction forces are applied at the joint only. Okay, kalau kita ingat sebelum ni, untuk 1D bar, kita punya elemen boleh apply, kalau kita dalam kita punya physical structure tu, dia boleh apply mana-mana kan. Let's say this is the center line. So kita boleh apply dia within the body. Dekat sana ke dekat sana, then kita jadikan that section sebagai kita punya tempat untuk kita jadikan dia untuk kita discretize kita punya structure kepada beberapa elemen yang lebih kecil. Tapi untuk So dalam this case, let's say this is our structure in 1D bar. So kita punya new nodes adalah nodes yang ni lah, merujuk kepada yang ni. And then kita akan ada 1, 2, 3 elements. Tapi untuk plane trusses, we don't have this such of apa tu the way where the point load apply. But in this case, the load as mentioned here, and also the reactions are applied at the joint only. So semua load yang kita akan solve nanti untuk plane trusses hanya akan dikenakan pada nodal point ataupun pada joint sahaja. So this is adalah joint dia yang kemudiannya kita jadikan dia sebagai kita punya nodal points. So in this case, we have 8 joints, which is equivalent to 8 nodal points. And then it's mentioned here, untuk plane trusses, kita punya problem dah expand kepada 2D problem. Sebelum ni 1D. So all the loads are acting in one direction. Dia ke atas ke bawah tapi dalam arah yang sama saja. Dalam satu dimension saja. Dia punya displacement pun which is in one dimension saja. Dia tak akan ada displacement pada arah ke kiri ataupun ke kanan kan masa kita buat apa tu 1D bar problem. Tapi untuk this kind of plane trusses, our problem now has expand to 2D problem. Two-dimensional problem. So that means here the displacement setelah structure ni, kita punya structure plane trusses, after we apply the load to the structure, then there is a possibility for the displacement at each nodal point tadi tu untuk displace in two direction, which is in the x direction and also in the y direction or in the vertical direction. So dia ada dua displacement dalam dua arah. Okay, and now let's we first look at dia punya numbering of our what we call it the displacement. Actually, there are many way of writing displacement. So dalam these examples, let's say if we look at this figures there, and these figures actually explain us, let's say if I am at nodes I can be any nodes lah, dia boleh jadi I pada node 1. So kalau saya pada node 1, so my displacement okay can be written as these two approach lah. The first one for the displacement in x direction equal to 2 I minus 1. So I adalah 1, 2i 2 multiplied by 1 equal to 2 minus 1 equal to q1, and then 2 multiplied by I equal to 2. So kalau saya dekat node nombor 1, saya akan ada dua displacement yang dikenali sebagai Q1 dengan Q2. So this is equivalent to what I have in the slide. Alright. If for example I am at nodes number 7, so that means my I here is I7. So I7. So when my I equal to 7, 2 multiplied by 7, 14 minus 1, 13. And then for the vertical displacement, I have 14. So kalau kita tengok all the numbers for the displacement for the horizontal displacement will have odd number ganjil. And then for the vertical displacement kita akan ada even numbers, number genap. Tapi dia ikut turutan lah. 1, 2, 3, 4, 5, 6, 7, 8. In terms of number node, kita punya displacement, kita ada 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sampai 15 dan 16. So that's one approach. Another approach, instead of benda ni kadang-kadang dia keliru. So another approach, instead of we write Q, we can write U to represent displacement in the X direction, and then V to represent displacement in the Y direction. Okay, so when we are at node number 1, then kita boleh tulis U1 and V1. Lagi senang kan? So pada node number 2, instead of kita tulis Q, kita boleh pakai U2 dengan V2. Dekat node number 3, kita pakai U3 dengan V3. So kita lebih jelas kan? Oh, ni berlaku pada node number 2. Displacement in X adalah U, displacement in Y adalah V. Give me 2 minutes.
You're welcome. You're welcome.
Alright, I'm sorry because I need to clear my nose a bit. Sesama sikit hari ni. Untuk sampai di stage, semua okey ke? Okay, saya assume semua okey lah.
Okay.
Alright. Okay, now we comes to the definitions of the local and global coordinate system. Alright, so kalau kita tengok tadi, kita punya elemen tadi ada yang inclined to certain angles. Okay, tak semua kita punya structure ni imperfect horizontal or verticals, but some of them which is inclined to certain angle, theta. So in this case, we have to treat our truss elements individually, and we have to view this in two coordinate system, first in the local and then global coordinate system. So for example, if I take this, so this is my plane trusses structure. So kalau saya ambil this element 38 kan, element 38 ni, and then saya besarkan dia, and then this is as shown in these figures lah. Tapi instead of saya pakai 38 tadi tu, kita just label dia 1, 2. Alright, actually these structures dia adalah part of the plane trusses. Dia actually dia segitiga kan, sebagai contohnya. Tapi kita just ambil one element of this from these triangles. Alright, local and global coordinate system are shown at left. Okay, local adalah maksudnya coordinate system yang merujuk kepada kita punya structure tu sendiri. So kalau structure kita in this direction, then we can draw a local coordinate system starting from there, and then in the x direction, x prime direction as shown in the slide. Alright, itu adalah untuk local. Tapi kita perlu ingat lagi tadi yang kita punya structure ni dia mungkin dia adalah plane trusses. Dia adalah dalam bentuk segitiga. Then this plane trusses is interconnected with other elements lagi kan. And then when to view our structures in a bigger pictures, then we have to use a global coordinate system. So the global coordinate system, which is often in the Cartesian coordinate system, and it is usually drawn as shown here. So x biasanya in the perfect horizontal direction, y in the perfect vertical direction. So this is a global axis or coordinate system, and then this is the local coordinate system. And from there, the nodal displacement in the local coordinate system. Okay, kita dah tengok which is in term of dia punya what we call it the axis itself, the local and global. Now let's relook what will be happen to the displacement when we view it in local coordinate systems. So when we view the our structure in local coordinate systems as shown, so the displacement pun actually happens in the q1 prime, which is displacement in the x prime directions. And at the nodes number 2, we will have q2, which is in the that move in the x prime direction. Dia jadi macam bar problem jugalah. Dia jadi macam bar problem. Kita ada bar problem. So displacement in this direction kan. Let's say saya ambil x prime macam gitu. So saya punya 1 dan 2 q1 prime dengan q2 prime in that direction sahaja. So this is when we view this in local coordinate system. So displacement akan berlaku dalam arah situ. Tapi this structure is inclined to certain angle theta. Then when we view this in the global coordinate systems, then macam kita explain sebentar tadi, that at each one nodal point, kita akan ada two displacement, 2 degrees of freedoms. Kita boleh panggilkan dia displacement ataupun degrees of freedoms. Displacement or biasanya kita panggil dia degrees of freedom juga. Darjah kebebasan kan, degrees of freedom. Degrees of freedom. So yang ni saya padamkan dulu. Nanti saya adjustkan. So untuk this position 2, and then kat sini kita ada Q2 tadi, Q2 prime. Alright, at notes number 1, I think we better use U1 and V1, which is the displacement in X and Y direction at nodes number 1. And then U2 and V2. Kalau nak pakai Q, tak apa, kita pakai U and V. Lagi better lah saya rasa. Ataupun kau tak nak pening kepala, kita ikut je dulu macam dalam slide ni. Nanti banyak-banyakkan pening kan. So in the global coordinate system, we will have Q1, Q2 according to kita punya apa tu? Kita ada apa? Q2I minus 1, Q2I. So if we apply these rules to our problem, kita akan dapat macam gini lah. Q3 and Q4. So untuk global coordinate system, we have Q1, Q2, Q3, Q4, which is refers to the displacement at each nodal point within our truss elements. And then in local coordinate system, kita hanya ada dua je, because we view in X direction, which is we have Q1 prime and Q2 prime. So kalau ada apa-apa soalan, stopkan saya. Otherwise nanti takut saya just continue. Tak ada soalan, nanti takut saya assume kamu apa ni semua dah faham. Alright. Itu very straightforward saja kan lagi kan. We go back sini semua dah tadi. Alright, we go back to this slide. So when we view the plane truss structure in local coordinate system ni, then dia kita punya the truss structure tu dia dah jadi macam when we deal with bar element sebelum ni kan. So bila kita tengok dia secara local, Q hanya dalam arah X, Q2 juga dalam arah X, which is exactly macam bar problem yang kita tengok sebelum ni. Cuma bila kita tengok dia dalam global coordinate system, kita dah ada 2 degrees of freedom pada setiap nodes. Maksudnya pada node 1 ni, dia bebas bergerak dalam dua arah, arah X dengan arah Y. Okay, next is to look at the relation. Yang ni pun very straightforward je. This is the transformation, how we can convert from the local coordinate system into the global coordinate system. So then we will come to these equations lah dekat sini. Equation. It's like a transformations matrix. It's like a transformation matrix. Okay, let's say kalau saya boleh explain sikit dekat sini. Let's say this is our the truss member. Kita just ambil satu truss member. Sebelum dikenakan loading, so dia duduk dekat situ je. Ataupun this is the original positions of our truss members sebelum kita kenakan load. Then after we apply the load, then this the deformation, yeah, we expect ada deformation kan in term of displacement to nodes number 1 and to the nodes number 2. So selepas kita kenakan loading, then assuming nodes number 1 now displaced kepada position yang baru, which is dia dah pergi ke sini, and then nodes number 2 also displaced to the new position for the nodes number 2. So dia dah displaced ke sini kan. Alright. Okay, then now from this we deal with the vectors and trigonometrics. So from position 1 to the new position of point number 1, so dia displaced dalam arah X by Q1 and they displaced in the vertical direction by Q2. Okay, sama juga pada nodes number 2, dia displaced dalam arah X sebanyak Q3 and then displace dalam arah Y sebanyak Q4. So from there, when we take the line that perpendicular to the our actually we project from here we project this a line towards our original positions of the our truss member. Then from there we can have one triangle so that we can solve for trigonometry. And then from this as well, if we project, then we can determine the Q2. So from this, we found out that this much of the this position lah kan, dia bila kita actually bila dia apa ni move in the X direction about this Q1, but when it move in the Y direction, bila kita projectkan this points towards our original position of Q1, actually yang kita nak tahu ni how much displacement in this direction yang dia dah displace, which is this is equal to Q1 cos theta plus Q2 sin theta untuk to refer to the displacement from the original to the new position of nodes number 1. And this is actually equivalent to the Q prime 1 when we view this in the local coordinate system. So sama juga berlaku dekat sini untuk nodes number 2, then we found that Q2 prime. So the total displacement in the local coordinate system ni, which is equivalent to this much Q3 cos theta, so about this much, and then we have Q4 sin theta, which is about this much. So dia dapatlah relation macam gini, and this relation we can write something like this, equal to, we have cos theta, sin theta, we have 0, 0, then we have 0, 0, sin theta, sorry, cos theta, and sin theta. So this is the what we call it as the transformations matrix. So dekat ujung ni kita ada Q1, Q2, Q3, and Q4. So this is if you would like to write this equation in the matrix formats lah. Sekejap. Okay, now we have the relation between the local coordinate system, displacement in the local, and also displacement in the global coordinate system, which is later on saya tuliskan dia dalam bentuk matrix format Q prime ataupun kat sini ni kita boleh simplify ni sebenarnya. So instead of write all Q's, saya boleh tulis dia sebagai Q je. So kita dah faham Q prime adalah daripada local coordinate system dan Q ni adalah daripada global coordinate system. Apa yang ada dalam Q prime? Q prime kita tahu tadi dia ada Q1 prime dengan Q2 prime kan. And then Q in global kita ada Q1, Q2, Q3 dengan Q4. Alright, now I can rewrite this equation in this formats. Tapi kita nak tulis cos theta sin theta sepanjang masa penat. Then what we can do, we simplify what we can by taking cos theta, which we can represent it by L. In some textbook, dia pakai C to refer to the cos, and we take M equal to sin theta. So nanti kita boleh substitute lah. Okay, kita dah faham cos theta ni adalah L, sin theta kita pakai M saja. And in some textbook, sin theta they use S instead of M. Saya tak sure dalam buku ni kenapa dia pakai L dengan M, which is I think S dengan C much more convenience kan. Okay, tak apa, kita just proceed je. So when we have this equation, cos kita boleh gantikan dia dengan L, sin kita boleh gantikan dia dengan M, yang ni pun sama L, M. So if we rewrite this, actually kita akan dapat benda yang sama je dekat sini. So this is the transformation matrix. Between the local and also the global coordinate systems. Yang ni you all kena faham sebab nanti kita akan guna benda ni di beberapa tempat yang lain lagi. Okay, yang ni I already explain, which is L. This metric yang kita ada tadi tu, this metric, the transformation metric, often called as the L matrix, capital L. And these equations yang kita ada ni, we can further simplify by calling it as the Q prime equal to metric L, which is the transformation metric, multiplied by our displacement in the global coordinate system. Tapi L ni, apa L? L adalah the whole things ni. Actually this topic pun senang je, cuma bila tengok yang dia punya theoretical ni, dia macam panjang lebar sikit lah dia punya explanation. But as engineer, you have to understand this. We cannot simply use engineer just nak cuba-cuba klik, try and error. Boleh try and error, tapi it often waste your time lah, wasting your time doing so many repeated testing. Alright, formulation for evaluating L and M. Okay, now we know that L equal to cos theta, M equal to sin theta. So considering our truss elements from node 1 to node 2, and then usually we know the coordinate system of kita punya structure. When we have structures and we put we supply the origin to the structures, and then basically kita boleh tahu coordinate of our structures kan. And then similar to this one as well, kita ada coordinate at nodes number 1, x1 y1, then kita ada coordinate at nodes number 2, x2 y2. Then from there we apply the trigonometry relations only. Ni pun dah belajar daripada sekolah menengah lagi. And then you can determine what is the L, what is the M, which is this information will be used in our K matrix nanti. Nanti kita akan tengok how our K matrix looks like. So yang ni I think very straightforward. I'm not going to explain in detail. Alright, now we comes to element stiffness metric. The element stiffness metric untuk plane trusses also derived from the potential approach. Alright, so we work with the internal strain energy. Kalau ingat lagi kita punya potential approach, kita ada U plus omega. U which is the internal strain energy, omega which is contains 3 other terms yang related to the loading kan. So similar to these plane trusses, we work with the internal strain energy, and then we work out from this stage sampailah we found that the element stiffness metric for plane trusses problem is given by this equation. Okay, this is kita punya element stiffness metric. Dia dah jadi besar 4/4. Kenapa 4/4? Sebab pada satu elemen kita ada 2 degrees of freedom. 1, 2, 3, 4. Then that's why we have a 4/4 element in the K matrix. And then what is contained in this K matrix, again sama je. We have geometrical informations of our truss element A, L. This is LE, which is referred to the length of our structure. Yang L ni adalah merujuk kepada cos theta dengan sin theta. Pun masih geometrical information of our structure kan. Cuma E sahaja yang merujuk kepada material properties. Alright. So equation ni tak perlu hafal. Usually we will supply this. And then the most important thing here, you recognize the equation to be used, the correct equation for a correct problems, and then how to use it. So that's why nanti dalam test ke apa, markah untuk kamu tulis equation tu dah tak ada dah kat situ sebenarnya. Sebab equation semua dah diberi kan. So exercise, kita tinggal dulu exercise yang ni. Then we straight away go to the system of linear equation. Alright, the system of linear equation that we are going to solve still remain the same as we did for bar problem, which is in the form of KQ equal to F. Cuma kita punya K now have changed to this forms lah. F sama juga, we have to look at the three components of forces. Kalau hanya ada point load, then we just deal with the point load. Kalau ada tiga elemen, body force, traction force and point load, then we have to consider all of them. Tapi jarang untuk plane trusses we ask you to solve for body force and also the traction force. So now let's look at this stress calculation. So in order to determine the stress calculation, similar to the 1D bar problem, we have to first solve the system of linear equation in order to obtain the Q. Kalau Q ni, Q adalah calculated from system of linear equation. If you didn't solve system of linear equation, the most probably you are not going to be able to solve the stress and strain and also the field displacement of your structure. The equations, ini pun jarang kita tanya untuk you all derive ni. Usually we will supply this equation so that you just apply to your problem. All right, I think that's all in terms of the theory untuk plane trusses. So this example here, which is a very good example to explain how all of this equation that we use for that we use in finite element for solving plane trusses problem are applied for solving these simple plane truss problems. So okay, saya rasa kita tak sempat nak tunjukkan yang ni. So what I can recommend to you, try to look at this example yourself first. Okay, tengok dulu macam mana nak solvekan these problems. And cuma dalam slide ni, the way it shows the step-by-step solution, which is as it is lah. Dia explain everything, and then you have to generate a very big system of linear equation. Kau tengok kat sini berapa? 8 kali 8 tak silap saya. 2, 4, 6, 8. Then I don't think you need to write this all 8 by 8 in your test or exam kan. So tapi untuk the first round for you to learn before we meet again next week, to look at this document first. Macam mana we treat this problem. We treat this problem sampai kita dapat jawapan akhir dia. And then try to pair. Okay, try to pair this example with the one that I share in my YouTube. In my YouTube, I have shown you a cut short approach to solve this problem, which I think it can save you quite a lot of times lah. I think silap-silap sampai lebih 5-10 minit kot. You can cut short your time as compared to the approach that you have in this slide. Tapi cuba tengok dua-dua. Okay, cuba tengok dua-dua dulu. Then next week kita discuss on this particular example.